Hello, this is Tim Timrawi, founder and CEO of Sharktech, a cloud hosting provider. In this video, we'll go through our cloud hosting service solution, discussing the details of the service, functionalities, and best use scenarios. Our cloud hosting solution is based on OpenStack and Virtuoso and is available at all 5 of our service locations: Los Angeles, Las Vegas, Denver, Chicago, and Amsterdam. The service provides you a virtual data center environment that allows you to create virtual machines, networks, routers, and other services and features. We'll go through them in this video. Our cloud hosting provides you three storage tiers: NVMe, a fast storage solution; HDD, a cold storage solution; and our default, which is an SSD-based solution. All of these storage tiers are fully redundant, complementing our hyper-converged compute infrastructure. This means that our systems are self-healing. All the virtual machines and resources you create are created on multiple physical nodes at the same time, with active and standby mode. And if the system detects a failure, your resources are switched seamlessly to the standby environment, changing it to active and recreating the standby instance elsewhere, ensuring the system's continued operations and eliminating the possibility of service disruption due to hardware failures. This gives you a hassle and worry-free virtual data center environment, allowing you to create the systems that you need without having to worry about the underlying hardware infrastructure, giving you the peace of mind that you are building your environment on a fully redundant and scalable infrastructure that provides you the scalability of resources you need without having to worry about building physical servers, storage, or network appliances. These resources are billed per hour based on your utilization in an easy-to-understand billing system that is guaranteed to be significantly lower than any of the big brand name cloud providers. As you can see, we are currently logged into our cloud control panel. On this page, you'll see a summary of the resources utilized and available. For the cloud package we are demoing right now, it shows compute we can use up to 16 CPU cores, 32 gigabytes of RAM, and 16 public IP addresses. In the storage, we are seeing the 3 different storage tiers, our maximum storage available, and what is the current utilization of each. The utilization of storage here is not based on the volume size you create, but the actual usage of the volumes. This package can be upgraded to allow more resources at any time through our customer portal. It'll show you how many virtual machines created, their status, and the highest resource using virtual machines. Now we'll go into the configuration part of the panel and go through all the available services and functionalities. First, we'll go to the virtual machines management page. We currently have 2 virtual machines running that we created for testing purposes. If we click on one of them, we'll see the available functions to manage the virtual machines and monitor its performance. We'll also have access to basic functionalities like rebooting the virtual machine, console access, or adjusting the virtual machine resources like compute, volumes, network, and access policies. Now, let's review the process of creating a virtual machine. First, we're going to click on here, and then we're going to specify the name of the virtual machine and specify how we wish to deploy the virtual machine, whether it is from an image or a volume that we have pre-built previously. For this test, we're going to use an image, and then we're going to click on Specify to select our operating system. As you can see here, we have a list of all Linux, BSD, or Windows operating systems available for us. We will also see a list of any images that you have created added to the system at a previous time. For this test, we're going to select Alma Linux 9.4. We're going to select that and click on Done. And here, the system has already created for us a boot volume that is 10 gigabytes and based on our NVMe storage tier. We're going to click on Edit and edit that and change its information, its access information. Here we can change the name of the volume, change the size of the volume, or change the storage policy. So for here, we're going to change the storage policy size to 40 gigabytes and then change the storage policy from NVMe to default. And here you can see that the system is going to delete this volume if the virtual machine is deleted, We're going to keep that selected, click on Save. Now we have the option to add, attach, or add an extra volume. If we click on Attach, this will allow us to select volumes that are available for us in our volumes list if we wanted to add that to the system. Currently, we have one that is data with 500 gigabytes, and let's say we can create that, add it, and click on Attach. And now this volume is going to be attached to the system storage. We can also add an extra volume by selecting here to create a volume. We can set its name, set its size, and set the storage policy we want. After that, we can select delete on termination if we wish that the volume is deleted when we terminate the VM, or keep the volume for later use. Now we have this done, we can click on Done. And now we have to specify the compute flavor that we want for this VM. Once we click on Specify, the system is going to show us a list of all available variances of our compute systems. Here we can select, I'm going to select 4 CPU cores and 4 gigabytes of RAM. Click on Done. After that, now we have to select the network interface. Now in here, we're going to go into more details about how to build our networks, but for now, we're just going to go and select from what we have available. So if we click here, it will ask us what network we want this network interface to be connected to. As you can see, we have two networks, private and a public. If we select this private network is completely disconnected from the internet and will provide the system an IP address on the 192.168 network. This network is completely disconnected and will not be accessible to the internet or public IP address. And this system this network will provide you a real IP address to this virtual machine. We can use that we can have it directly connected to the internet. We're going to click on private. And now we can select the configuration for the IP addresses of this network interface. In here, it has a primary IP address, which is going to pick it up from the DHCP directly, or we can uncheck this and specify the IP address that we want ourselves. We're going to keep it selected. It also will allow us to add secondary IP addresses to the virtual machines as well. We're not going to select any here, or the security policy, and we will go into that in more details of how to create a security policy and apply it to the system. We're done here. We're going to click on Add. Also, we can add additional network interfaces if we want. In here, we can add as many as we want from any of the networks that we have already created. So we're going to click on Done. And now we have specified the network interface. And after that, we have to specify the SSH key. This is mandatory if you're using any Linux image that you need to build from. This will allow you access to the console of the system through SSH, through basic SSH. Here we have already created an SSH key, and we will show you the process of how to create an SSH key as well. We're going to select this. We're going to click on Done. And in here, if we want to create any script to use on the boot up of the system, we can specify that script here. It can be a shell script, a cloud config, or any of the cloud init as well. We're not gonna set up any of those, and we're gonna keep on going. And then after that, we're gonna click on Deploy. And now the system is gonna provision this VM using the pool of resources that we have, and it's going to go through the process of assigning the compute resources, the storage, building up the storage volumes that we have decided, and bringing it up online. As you can see, it's already done and it's ready. We can click on console here and see where the system is at on the first boot up, or we can adjust the configuration that we have used already, whether we want to add or edit the network interfaces, security policies, add additional storage tiers, modify the storage, the storage tier of any of the volumes that we have, or monitor its performance, or monitor its current performance. And that concludes building up a virtual machine. And we will go further now next to the next subject. So next we have Kubernetes. And I must admit, I am not familiar setting up Kubernetes clusters, but from feedbacks I received, it works. It will create the master virtual machines and all the necessary compute nodes and provides you all the standard functionalities. You can select the cluster name, build up the information for it, which network you want to connect to, how many master nodes you wish, and it will also create the container volumes and all the compute default worker groups that you want. If you need any additional assistance or have any questions about this process, please feel free to reach out to me and I will connect you to one of our Kubernetes experts. Next, we're going to go into images. Here you can see a list of all available images we provide and images that you have created. As I said before, we make sure that images we provide are updated weekly on weekly basis. You can upload your own image and it will be added to your cloud service. So if you can select the image here, browse, select the image, and as you can see here, you can use ISO, AKI, AMI, image, ploop, QCOW, RAW, VDI, VHD, VHDX, or VMDK. Once you have selected the image, then you can provide it a name, and then generally using generic Linux will work unless it's Windows, and then you can select Windows here. Once you have selected that, you can click on Add, and the system will upload this image to the system and will be available here for use. Also, you can also upgrade and add, create a volume from an image that you have created by selecting the image that you have uploaded, then selecting Create Volume, or download the image back to your system. So for example, if you have a volume that you need to migrate from our cloud to another cloud, you can convert the volume to an image. Then this image, you can after that download this image, or you can create a volume from an image that you have imported from a different cloud setup. Next, we're going to go to volumes, and in here we're going to see all the volumes that we have created from the virtual machines that we have created, or we can create new volumes. In here, we can manage these volumes, make changes to them, whether we want to change the size of the volume, change its name, change the storage policy of it. If we change the storage policy, for example, from HDD to NVMe, the system will automatically change this seamlessly in the background without any kind of service disruption. We can detach the virtual machine, the volume from the virtual machine that we have, create a snapshot, or create a backup of the volume directly. In the snapshot, for example, we can see that we have already created a snapshot for this volume. And in here, we can create a volume from the snapshot, create an image, or revert it back or delete the snapshot. Also, it's good to know that we can create, for example, an image from this volume that we have created. This image will then go back to images, and we can download this image to store it elsewhere. So now we have gone through images, volumes, and how to create a virtual machine. Let's go to the fun stuff, the networks. So in here, when the system is created initially, it will only show access to a public network right here. What this means is anytime a virtual machine or a resource is assigned to connect to this network, the resource or the virtual machine is going to be provided a public IP address. This means that the system is going to be directly connected to the internet. And this is not usually the best use scenario. And it's best that we use a private network and then manage our network connections through that system. So to create a virtual network, once we create a virtual network here, the system is, this virtual network is completely private, and it will not be initially connected to the internet unless we specify through a router and floating IPs at a later time through this video. So let's go here and start the process of creating a virtual network. We're going to click here, we're going to click create, and in here, as you can see here, there is IP address management. So let's say, for example, you want to create a virtual machine, a virtual network, but you do not want the system to manage the IP provisioning or the IP management of this network. For example, you have your own server that is going to be handling the DHCP of the service, and you do not want the system, the cloud infra managing the setup. We would uncheck this box, and this system will just create a VXLAN network without managing the IP addressing of this network. For this test, we're gonna keep the IP address management enabled. We're gonna name this network test and click on next. After this, now we have to configure the IP address subnet for this network. So we're gonna click on add, click add IPv4, and in here we'll have to specify the CIDR for this network. Let's go for 10.254.0.0/24. And let's go, and here it's going to ask us to specify the gateway. Now, heads up on that. So this is basically means that the system needs to know the IP, the gateway, if you are going to eventually add a gateway to this network to make it connect to other networks. When you specify this here, that does not mean that it's going to create a router or a gateway for your network. It will just provide this IP address as the gateway in the DHCP handoff that is going to be providing to your resources. After this, it'll ask us if we want to provide DHCP, this information to in DHCP form. We can uncheck this box if we don't want it and we want to specify the IP address ourselves, or we can keep that checked and then tell the system the IP pool, the allocation pool to use as a handoff for DHCP. So for example, here we're going to go for 10.254.0.10 all the way up to 10.254.0.254. Then check the checkbox here. And then in DNS servers, you can select whatever DNS servers you want. For this test, I'm going to use the Sharktech DNS servers. So 170.178.181.66 and 170.178.191.67. And now once we click done, it'll show here that this is already configured. We can click next. And in here, it'll show you a summary of the network that we are creating. It's VXLAN based network. Its name is test. It's an IPv4 network with the 10.254.0.0 as a /24 as a CIDR with DHCP enabled. The gateway that is specified in DHCP, the allocation IP pool, and the DNS servers that it's going to be handing off. So this is the information that's going to be handing off and using for any new system that is specified, that is connected to this network. So we're going to click here and click on create a virtual network. And the system is going to build that virtual network and provide us information for it right here. So now we have created networks. We're going to go ahead, skip over VPN for now and go to our routers. So here we can create basically simple routers that will connect our networks. We can enable source network address translation, which will allow our network to connect to the internet using many-to-one NAT connections. This will basically have your system on the network able to initiate communications to the internet, but not the other way around. All the systems will use a single public IP address unless we specify a system-specific floating IP address, which we will go into later. We can also create additional network interfaces on this router to interconnect private networks that we have, and also create static routes connecting other networks internally. For example, if we have a VPN server inside of our setup. So let's go ahead and create our first router now. We're going to click on add router. We're going to select name, specify name, let's say default. And in here, we're going to specify the public network for our physical network access. This is where we're going to be NATing to. And in here, as you can see, SNAT is already enabled by default. And this will basically replace the VM private IP address with the public IP address that is specified here when connecting with external networks to the internet. After that, we're gonna specify the internal networks that we want this router to be connecting to. So as you can see here, we can add multiple networks. So here, when we select a network, for example, let's select the test network that we have just created. And if you see here, it does not allow us to provide the IP address. It's going to pick up the IP address that we provided in the DHCP setup configuration. So because we provided in the DHCP configuration 10.254.0.1, it's going to use that as the IP for this router. We can also create additional internal network interfaces. For example, if we want to interconnect our two private networks. So let's go ahead here and select the other private network that we have. The same thing the system is going to do here. It's going to take 192.168.0.1 as the address for this third interface. So now we have our basic router configuration done. We can click on Create. Now the system is going to pull out an IP address from our public network, enable SNAT on that, and associate it and create two interfaces, internal interfaces, one that is 10.254.0.1, and the other one is 192.168.0.1, and associate them with their proper networks. Now that is done, you can see here that the system is active, this external network is public, and SNAT is enabled. We can adjust that here. As you can see now, the system has assigned 45.58.177.125 as the public IP address for this NAT, for this external gateway, and taken 192.168.0.1 for the private network and 10.254.0.1. So now that means that if an IP address on this network wants to communicate with 192.168.0.1, this router will be responsible communicating between these two networks. If one of these networks trying to connect to the internet, it will replace the IP address of the system that is trying to connect to the internet with 45.58.177.125 and connect it to the internet. We can also add static routes, as we discussed earlier. For example, if we have a VPN server inside of our network, and we want to specify where we want that network connected. So for example, let's say we have 192.168.2.0/24 is our VPN connection, VPN network somewhere else on our network. And we can say this network is connected through 0.25, for example, which is an internal virtual machine that we have. Now, when this happens, the system knows that it will send any traffic that is destined to 192.168.2.0/24 to the next hop that is on its network in the 192.168.0 network. Once we click on Add, now this is going to be available as a static route and added to our route. So setting up a router is really important because it will open up two other features for us, which are VPN and floating IP addresses. And that's why I've skipped over VPN to set up this. And next, we're going to go through configuring our VPN setup and looking at that. So now we have created a router. We can go ahead and go back to VPN. And in here, we can create site-to-site VPN tunnels. This is IPsec tunnels that are designed to connect two private networks together over the internet. This is a useful scenario. For example, if you have your office, you want to connect your office to your cloud infrastructure, or you want to connect your cloud infrastructure to another cloud provider. And here, for example, we're going to click on Add VPN. We're going to specify the IKE policy that we want, and this is a new policy. We're going to give it a name. This is standard configurations. You will share this information with the other side of your VPN tunnel. Let's go for SHA 256, AES 256, IKE version, and the Diffie-Hellman group. We're going to click on Next. And this is phase 2 of the IPsec tunnel. We're going to create also a new policy. We're going to call it demo as well. Again, we will specify the encryption for phase 2. And after that, here we will select the router, which we have already created. This will then now mean that the system is going to use the external IP address of that router to connect to the VPN. It will ask you now to create the local endpoint group. So this is the local network that you want this VPN tunnel site to connect. So for example, we're going to be connecting the two networks that we just created. We're going to call it internal. And then in here, we're going to select which network we want this VPN tunnel to be connecting. So we're going to go for the 192.168. We can select both of them if we want. And after that, the remote endpoint. So again, here, we will also do the exact same thing. What is the network on the other side of the tunnel that we were going to be connecting to? So for example, 192.168.2n.0/24. That's the other network that we want to connect to. Oh, I'm sorry. This is the name here. So we're going to say Las Vegas. And then in here, we're going to specify the subnet. So 192.168.5.0/24. That's the network, for example, for our office network. We're going to click on next. And here we're going to say specify the VPN name that we want, Las Vegas. We can go to advanced and go into more details of the VPN tunnel, but that's not necessary in most cases. We're going to select now. Here we have to specify the public IP address of the peer. So this is the other side of our VPN tunnel. What is its internet address? So let's say, for example, I don't know, we're going to use another IP address from here, 25, and the pre-shared key. So this is a key that we will share with the other side of the VPN tunnel so they can authenticate with each other. We can generate the key here. And once we have all that information, it will provide it to us all in a summary. We should probably copy this and share it on the other side of the VPN tunnel so we can configure this tunnel on the other side. Once we have that done, we can click on create, and the system is going to create that site-to-site VPN tunnel for us, and it's going to show up here. So this tunnel is currently down because we do not have the other side configured. It will show you the peer IP that it's going to be trying to connect to, and what is the local network communication. So as you can see, it has picked up the router external IP address, 4558.177.125. That's the IP address that it's going to try to connect from, and it's going to connect to 45.58.125.25. That is the IP address that it's going to try to connect to. Else here, we're going to see that it's the public key that is available, the MTU, the initiator mode, which is bidirectional, the DPT policy, and the intervals. It will also provide us the information about our local point and the endpoint and the IPsec policies. It'll allow us to edit this policy or restart this policy if we want to try to reinitiate the session. So this setup is great for using, if you want to connect, create your own network environment in the cloud, and then connect it back to your private office, or have multiple different network connections that you want in cloud, and you want to connect them directly to your network infrastructure here. So now we're going to go to floating IP addresses, and basically what this is a one-to-one NAT service. It'll allow us to basically create a NAT that will connect our public IP address and connect it directly to exclusively to a one IP address internally. This is useful for basically when we want to create, for example, a web server, and we want to make sure that it's a static IP address dedicated exclusively for this website. So for example, if we want to create here, we can go and create an add floating IP address. We would select our external facing network we want to take an IP address from. So it'll select the public, and this will assign us a public IP address for the external network connection. And internally, we want to select the virtual machine that we want to NAT. So let's say we'll go ahead and go for demo, select its primary IP address. So now we're creating an external IP address, and it's going to be NATed, all of it, to this address, 192.168.0.223. And any traffic from 192.168.0.223 that wants to connect to a network that is undefined by our network lists, it's going to be translated to a public IP address and goes to the internet from here. So once we click on add, the system is going to create the NAT policy for us and brings it active online. And now here we go. So now 45.58.177.68 is active and is going to be translated and connected, transferred. All the data that connects to this IP address is going to be going to 192.168.0.223. So this is basically a good feature to allow us to manage our internet access. So for example, if we need to ever disconnect this IP address to a different virtual machine, we can just click here, unassign, and once we do that, the traffic is no longer going to be routed to this virtual machine. After that, we can click on reassign and, for example, reassign it to another virtual machine. So we can, for example, go here, click on assign, select the other demo server that we have, select this IP address, click assign, and now the system is going to be routing all traffic going to this IP address to 192.168.0.210. So now we have created the floating IP addresses. Let's take a look at the load balancing function. So in here, we can basically create a load balancer that will take one IP address and load balance it to the back end to multiple systems behind it. This is great for systems where we want to create a heavy load traffic system that we want to distribute the load on multiple different virtual machines in the back end and monitor these systems' performance and make sure that these systems are available and pull out any system that is having issues and have the system automatically control the load. In here, for example, we're going to click on create. We're going to select demo for a name, set it up in high availability mode. So this will create 2 instances of this load balancer, ensuring that the load balancer is always active. Select the network that we want this IP address to be assigned from. So if we want this load balancer to be publicly accessible, we want to use a public address, or we can use a floating address as we discussed before. Give it a private IP address and let it use a floating IP from that. So let's go here ahead and create it in public. And in here, we'll have to specify the pool. So we're going to click on add. And after that, we can select what are we load balancing. So if we want to load balance, for example, HTTPS traffic, so the system is going to take HTTPS traffic and use that and transfer it internally to another HTTPS web server, for example. We can select here how to do that. If you want to change it from HTTPS, take HTTPS and give it back to HTTP, we can select here and specify the SSL certificate that we want to use. HTTP to HTTP, so that basically means that it's just port 80 coming in and port 80 going back to our internal systems. Obviously, if our internal systems, for example, are using different IP addresses, we can specify that here in the back end ports. So let's keep it here selected at 80. We can also add HTTP headers. For example, if we want to add X forwarded, forwarded port, or protocol. Let's keep that disconnected. Obviously, also here we have enabled TLS encryption and enable proxy protocol. Else than that, we can also use basically basic TCP to TCP traffic. So this means it's a standard TCP session. For example, if we have something that is not a website, we can say the port for it and the internal port, and or UDP, where basically it is the same thing. So it's a different protocol, and we're just, for example, if we want to load balance, we have a pool of DNS servers, and we want to load balance through here. Next is going to be the balancing settings. So the algorithm that we want to use for the load balancing of the system, whether it is for least connection. So basically the system is going to monitor how many connections it's sending to each one of the nodes in our pool. and decide based on that which virtual machine is going to be sent the next connection. Round robin, which is randomized round robin. So basically, it's just going to go 1, 2, 3, 4, 1, 2, 3, 4, or source IP based. So that means that it's going to be pretty much a sticky session that will make sure that any session that is created is going to always be going to the exact same system in the backend. So let's go here, click round robin. So as you can see, because we selected UDP here, there is no sticky connection because UDP is, as it comes in, it goes. So it's not going to be selecting any of that. After that, we will select our member virtual machines. So as you can see here, we have one virtual machine that is only on the accessible to the public interface. If we selected private network in the initial setup, it will have the other interfaces, networks that we have, systems that we have. We click on add, and next we have the health monitor. So the system is going to be constantly checking these back-end systems to make sure that they are accessible. We can here select how we want to check it. So if we want to check it for TCP, we can add the parameters here and specify how often the system is going to check, what's the timeout, how many successful attempts. For example, if the system becomes inaccessible, it's going to take it offline, but after that, how many successful checks it needs to see before it brings it back online. So once we have that all done, we will click on create, and the system is going to create the session for us. And the load balancer now is going to be available to us here. It has created it. It's specified the IP address for it from the outside, and it's going to show us the member state right now. So it's obviously it's going to be down. And here we're going to see the member state status, the network, how many error requests we're seeing, the active connections, and the properties of the load balancer that we have created. Obviously, at any time after this is built, we will be able to add more back-end systems and manage this load balancer as well. So next, we're going to go to our backup plan. So this system has the ability to create scheduled backups. So it'll allow you to create a backup and make sure that the system is automatically backing up based on a retention policy that you create. So for example, if we create a policy here, we can select the volumes that we wish to back up. It will show you an option here for what volumes we want to add in this backup policy. Select the retention policy that we want, whether we want to keep the data for a custom period, which we will select here, or a policy that is keeping the data for 14 days and how many recovery points we want to create, and the date and the times that we want to create the policy for. So I have already created a policy here, if you see, and it already is creating, it's backing up one of the volumes, and it shows here that it has already created one recovery point. And if you see here, we can see that we have one data point. We can also click here, manage, and select an additional volumes that we want to back up. Click on save, and these volumes are going to be added in our policy, in our backup policy, and it will allow us to create backup for these. After you do this and the system has run the backup policy, then we will see the backups created here in our recovery points. It has created one backup already for the data volume, and this is now available for us, and we can restore our data from this backup. Last but not least is the SSH keys. So in here, you're going to see the list of the SSH keys that you have created, or create a new SSH key. So as I discussed before, when we were creating a virtual machine, we specified the SSH key. So this is important for any Linux operating system, virtual machine, or Kubernetes cluster you are creating. The system is going to ask you to specify the SSH key, and this is needed for the initial connection and initial communication over SSH to the system. Here you can create additional SSH keys, specify their names and the key value, and after that they will be available to you to use. So that's it from the perspective of our customer, of our cloud platform overview. In here, we have more documentations and API information available through our customer portal. Next, we're going to be going through our website, how our packages are designed, and how to manage our billing for our system. So now we're going to go forward with how to order our services and the kind of packages that we have available. So if we click on cloud, we're going to see two public cloud options that we have available. Both of them are the exact same product. It's just they differ in our billing structure. So public cloud provides you the ability to be billed per hour for the resources that you're using in excess of your initial commit. So for example, our small package comes with the included commit levels listed here, and will allow you to exceed the included commit up to the levels that are shown right here. Any time that you are using resources above the included commit resources, you are going to be billed per hour for the excess use right here. At any time, you can upgrade your package to any of the other tiers that we have available, and that will update your included commit and increase your maximum threshold. So all of those are going to be billed per hourly basis. So for example, if you temporarily needed to create a development system for a few hours or a few days, the system is going to be billing you for those resources used for just a period of time that you have used them. The only caveat of that is our public IP addresses, which is going to be based on the maximum IP addresses used in the month period. And our bandwidth, which comes with 5 terabytes of outgoing bandwidth. And just to clarify again, this is only for public internet access. So that means that any private network communications that you have it's not going to be included in this. And it will charge you per gigabyte for the outgoing bandwidth that you have used for the monthly period. At the end of the month, you will receive a bill that has your basic package price and any additional bandwidth, any additional resources that you have used for the period of time that you have used them for. So that is from our public cloud solution that is available on hourly basis. Next, we have the dedicated cloud. And in this setup, you are billed as you go. So for example, you are prepaying for the service. So that means that this service is going to have a commit level exclusive for you, and you cannot exceed that, that amount, and you will not be billed on hourly basis. In this setup, you will specify the amount of compute power that you need, the storage limits that you need, and you will be limited to this resources. If you decide that you need to increase your resources, you can go through our customer portal at any time, upgrade your package, and at that point, the system will prorate you for the period of the month and bill you and update your package for you. This is it from this perspective of the two packages that we have. Ordering the service is pretty straightforward. Going here and clicking on deploy now, this will instantly create the package for you. It will take you to our order page, which will allow you to select the data center that you want the service deployed in. Select the tier of service that you wish the system to be created. Click on add to cart, provide your contact information and your billing information. And once all of that done, then it will create the service for you and add it into your system. So after we have selected the package here, filled in our information and submitted the order, the service will be instantly available through our customer portal. We would log into our customer portal and the service would be available here in our products and service as an active service. In here, we can click then on the service. This will open up the service page for us, providing us information about this package and some functionalities. So for example, through here, we can upgrade the package, change its commit levels. It'll provide us information about the details of the service, where it's located, its status, and the resources available to us. It will also provide us the access information for our cloud panel. And the access information for this, the username and password. After you use this information, you can go through our customer portal, our cloud panel, and reset the password there. Inside of here also, you will have access to our knowledge base information and our API access keys. It will also provide you the current usage records per hour, how much memory you have used per hour, CPUs, network connections, and all of that information. It will also then provide you the billing information for the package. So basically here, it's going to provide you hourly base rates of how much you are incurring in costs per hour for the overhead, for the overage that you are using. So if you see here, we are using for the last hour 12 gigabytes of RAM, 12 CPU cores, 0.02 gigabytes of RAM, and 0 for outgoing network traffic with 1 direct IP address being used, and 1090 gigabytes in storage. And then it will show us the spread between default storage, HD storage, and NVMe storage. And then how much per hour you're being billed for these resources. You can also download this as a CSV file, and it will provide you all the records that we have on file for the resource utilizations that you have. And you can use this graph and it will show you the basic utilizations that you have used for this package. This is it for us from our cloud information. I hope you enjoyed this video. Thank you for going all the way with me on this whole video. I appreciate it. And hope if you have any questions or concerns, please feel free to reach out to me through LinkedIn or through our website. Thank you. Bye-bye.